Robbie, I'd say you could start. This looks like everybody.
Okay. Well, thank you all for coming out to our 2022 Montgomery County Water Quality Training. My name is Robbie O'Donnell. I'm the Watershed Program Manager with Anacostia Riverkeeper. Christine Burns, our project coordinator, is here, waving in the background. um, we're going to record this training just so we can put it on our YouTube, and any other folks who you tell about this or who want to get involved can come to another training that we're going to have on the 20th. But also, if they can't do that, then they can train virtually via that video that's recorded. So just a heads up to everyone. But with that, we'll get started. This shouldn't hopefully take until 12. Should probably take until around 11:15, 11:30. If you have any questions as I'm going along, please type them in the chat, and I will be sure to address them as I'm going along. But let's get started. Fine. Now let's get started. So this is our second year of this exact project, our third year monitoring around Montgomery County expressly. And this project is funded through Montgomery County's Department of Environmental Protection, Chesapeake Bay Trust, and then we're also partnering with Friends of Sligo Creek and Neighbors of Northwest Branch. Pat, I believe, is here from Friends of Sligo Creek. Do you want to say anything, Pat? Or going once, going twice? And so that is our team for this year. Like I said, this is our third year. We had this program last year as well, which was pretty great. We're continuing it this year to hopefully get some more water quality data in a lot of primary Montgomery County streams, expressly tributaries to the Anacostia. And so the biggest question about this project and why we want to get funding and why folks at Friends of Sligo Creek and Neighbors of Northwest Branch have joined us is what's going on in these waterways that would require monitoring, and why do we need to monitor them in the first place? So here's the Anacostia watershed in all of its beautiful urbanized glory. Um, our office in Anacostia Riverkeeper is based down in DC there, kind of towards that 295 sign. But as you can see, a good portion of the watershed, I believe around 2/3 of the watershed, or just over 2/3 of the watershed, is in Maryland, Montgomery County and Prince George's County, Maryland. And so, as all good things, and water flows downstream with gravity. And so a lot of the things that can impact the main stem Anacostia are actually occurring in the upstream portions of the watershed. And so that's why we typically like to monitor in the upstream portions of the watershed, because you're able to get a better understanding of the overall watershed health, not just the main stem, by monitoring in all these select tributaries. We don't have monitoring in all these tributaries, but we've kind of picked the primary tributaries, the largest tributaries to the Anacostia, and the ones that are either the most urbanized or have had a history of pollution and things like this. So as you can see in this image, and this is I always like to use this image because it's a perfect example of why we are monitoring. The image on the left is impervious paved surface in 1984 around the DC Beltway. You can see DC there in the middle with Tyson's over there to the west a little bit, kind of small. College Park there to the north, and then Joint Base Andrews over there kind of to the southeast. And now if you fast forward to 2010, you see all of the blue, which is the impervious surface, has expanded. You can almost trace the beltway all the way around the DC area. And that's in 2010. So it's 2022 now, almost halfway through 2022. So that's probably expanded by 2 times now. So what this is getting at is that we are a highly urbanized watershed. About 25% of the Anacostia watershed was labeled as impervious, and it's only grown since then. I believe around 75% of the watershed is considered developed. So those are kind of similar stats, but presented in different ways. So we are a highly urbanized watershed, which means we have urbanized issues with water, i.e. our rainwater, our precipitation, our sewage water, all these things are flowing in and around our natural water bodies like the Anacostia or Sligo Creek or the Northwest Branch or even the Potomac or Rock Creek over there in the Potomac watershed. So there's some issues in our areas. And you may see these along the street, you may see them along a tributary, you may see them along a stream or on the river. Anytime it rains, snows, sleets, fogs, anything like that, any precipitation, all that water is basically hitting the ground. And if you have an area that's 25% impervious, as some of you may know, that water is just going to run off and not be able to infiltrate into the ground. So a lot of it ends up in our stormwater system, those nice drains you see on the side of the road with a big placard that says this goes to the Chesapeake Bay, which you can see there in the bottom left. Um, all those systems, for the most part, at least in this upper part of the watershed, will feed into tributaries. A lot of stormwater systems, and most stormwater systems, will feed into our streams and tributaries, bringing in with them anything that was sitting on the road, whether that's trash, whether that's road salt, whether that's fertilizer, dog waste, oil, anything like that. That is going to come into our watersheds, hitching a ride on the storm water that is coming in via snow, precipitation, rain, anything like that. So anything you see on the street could at some point, unless you pick it up or it goes away, could at some point end up in the streams, end up in the tributaries. So when you have these natural bodies of water, these natural streams flowing through highly urbanized areas like around Silver Spring, College Park, Colesville area, all these areas, then you can probably put two and two together and see that our streams are at an increased threat for pollution from all these many things. Raw sewage can also enter in if you have old sanitary lines um, running underneath tributaries. These are two examples in DC. These are old trunk sewer lines that run basically along or through tributaries, and these are some of them are old in some areas. Some were even built out of wood. These are a little bit newer, but still relatively old. So some of these sewage pipes can leak, they can crack, they can break. Um, there can be illicit hookups, there can be all these different things. So it's just stormwater runoff, but can also be just leaky sewage pipes. So you can actually have sewage potentially coming into these tributaries as well. So as you can see, what I'm getting at is that we have a large issue with potential pollution entering into our waterways, whether it's trash, whether it's uh, like PCBs, PFAS, all this type of stuff, any type of urban pollution you could have potentially in our waterways. So with this monitoring program, what we are primarily focusing on is bacteria, specifically E. coli. Um, and what we're focusing on broadly is recreational water quality, and I like to call it ecological water quality, or basically, is that stream safe for humans to contact, and is that stream healthy enough for our macroinvertebrates, our fish, our other small aquatic or amphibian organisms to live in? So if that stream had no bacteria and really great ecological conditions, it would be a nice, beautiful, pristine stream that we could go swimming in and touching, and there would be fish abound. But that sometimes isn't the case because, like we said, we can have E. coli coming into our waterways. We can have poor dissolved oxygen, high turbidity, things like this. So these are what we are expressly monitoring for. We monitor for E. coli is because E. coli isn't really the thing that's going to get you sick if you were to come in contact with it in the water. But it's what's called an indicator bacteria, which means if we have high amounts of E. coli, if we read high amounts of E. coli in the water, that indicates that more nefarious bacteria could be present and at higher volumes. And so we're basically testing this against EPA Maryland standards, and then testing our ecological or our biological health indicators like dissolved oxygen, specific conductivity, against national standards as well. So this is the primary set of water quality parameters that we are testing for. And this is the list expressly. And so what volunteers like y'all will be testing for is simply air temperature, water temperature, pH, bacteria, and turbidity. So those are field samples you will go out and you will read and collect, and then we analyze them in our lab. Our water quality folks also go around with a water quality probe, basically a calculator with a sensor on the bottom of it, and they also go behind y'all and test for things like dissolved oxygen, specific conductivity. And this year we're actually sampling for nutrients in the water as well, so total nitrogen and total phosphorus, to basically get at is there too much nutrients from fertilizer or golf courses or things like this. There's potential for too much nutrients in the water to breed algal blooms and this types of thing. So we're adding that to our list for the first year this year. But these are the general set of parameters that we sample for under this project each year. So that's a little background on why we're monitoring. because obviously can come in contact with all of these waters. We like our waters to be healthy. That way, our fish and our wildlife are healthy. But also because across Montgomery County, even with these small tributaries, people are coming in contact with this water every single day. So where are we monitoring? So for the second year in a row and the third year in some locations, we're monitoring primarily along Sligo Creek, along Long Branch, and Northwest Branch. So these are 5 tributary sites, 3 along Sligo Creek, 1 along Long Branch, which is a tributary to Sligo Creek, and 1 along the Northwest Branch. The 3 Sligo Creek sites go pretty much from Wayne Avenue and then trickle down towards Tacoma Park. Long Branch is right by Rolling Terrace area, and then the Northwest Branch 1 there, that is, or Northwest Branch 2, that should be called. That Northwest Branch site is next to the Burnt Mills location there, where the trails are and everything like that. So these are areas that we chose with help from Friends of Sligo Creek and Neighbors of Northwest Branch, because these are highly public areas. They're through urbanized areas. They are areas around high recreation. They have trails. There's been noted water contact here, whether it's through swimming or wading or anything like that. So these are some primary sites that have also had poor water quality in some instances, whether recreational or ecological, for the past 2 or 3 years. So these are our primary sites that we monitor for. And thankfully, each year when we're monitoring these sites, we send our data, the data that y'all collect, to Montgomery County DEP, the state of Maryland, Montgomery County Parks, Chesapeake Bay Trust. We send all this data out as well as publishing it to the public, just so it's in the hands of the folks who are making decisions, policymakers, stuff like this, and they can make the best decisions based on the most updated and current water quality data. So now we'll get into the actual monitoring steps and process. So this is kind of what is expected of a volunteer under this project. Like I said, we're in Montgomery County. All these sites are, as you can see, are within a relatively small cluster of areas. Like I can get to each and every one of these sites probably within 30 minutes of each other, just reaching all of them in that same amount of time. Monitoring at each site will take 10 to 15 minutes. So thankfully, they're relatively close to each other, so you can hit them all, or volunteers can hit them all pretty easily, depending on where you live. And they're all very accessible. They have parking, they have trails, they're all streamside and easily accessible. So this is all what fed into why we chose these sites. So now we'll get into the monitoring steps and processes. So first things first is safety. I know monitoring in the summertime when it's nice outside in the morning sounds like a lovely little day out, but we do like to be safe. So follow instructions in our digital training manual that we'll give y'all at the end and you'll have access to. We won't sample in dangerous weather like thunderstorms or high water or anything like that. We typically sample in teams, whether with other volunteers, you can go out with family members or friends or anything like this. We won't use any broken materials, obviously. We always like to wear gloves when we're taking samples. One for the benefit of the sample, i.e. you don't want to bias the sample with dirty hands or something like that. But also, obviously, for y'all safety. We're testing for potentially harmful bacteria. So if we're wearing gloves, we're going to lessen our contact with that potentially harmful bacteria. Um, keep track of your trash. We'd like to leave no trace here. We don't want to go out and sample for water quality and then produce more pollution. And then always refer to contact sheet or project contacts, which we'll provide as well if you have any questions or concerns or anything like that. Also, as someone who's worked primarily outside for most of their life, always watch out for ticks in the summertime, especially around here, snakes, things like this. We actually last year, a group at the Northwest Branch saw a pretty nice, maybe 4 foot long black snake that was pretty cool. So they are around. Just keep an eye out for them always. So what your volunteer responsibilities are. These 2 pictures over here on the left are actually 2 pictures of our sites. There's Anne at the Northwest Branch site, and those are some 2 volunteers down there at, looks like Sligo Creek 1, I believe. So they're pretty nice sites, nice little morning sites to go to every other Wednesday morning in the summertime. But these are your responsibilities as a volunteer. So why we have these trainings on Wednesdays or Thursdays usually in the morning time is typically that's because when we monitor. Um, so we like to sample between 7 a.m. and 12 p.m. on Wednesday mornings. So the sampling frequency and schedule for this program is every other Wednesday morning, starting on May 18th and then ending middle end of September time. So it's biweekly. So there's only about 11 monitoring days specifically throughout the summer. So it lessens the time burden a little bit on y'all. Um, Vacations we know happen, scheduling conflicts happen, we know. So we try and do this a little bit at a decreased frequency to help y'all a little bit and go and sample a little bit more. Obviously, we won't go out and sample if there are hazardous conditions. If we're not sampling on Wednesday, we will email you, let you know, in which case we sample on Thursday. Some people are able to sample on Wednesdays, not on Thursdays. We'll explain that here in a little bit, but that's our typical schedule for monitoring. Um, You'll have a designated person in your monitoring team who you can talk to. You can talk to your coordinator, which would be us at Anacostia Riverkeeper, to drop off your samples. We drop off our samples at the Tacoma Piney Branch Park, which is kind of centralized right around all of these sites. So that's an easy drop off location within a couple minutes of all the sites that you can drop off your samples at. And you'll then record all of your data on a field sheet, which is just essentially physical information about the site, and then also a chain of custody site, which is basically an index or a list saying what samples you collected, and then basically denoting the passage of samples from the sampler to the lab, us at Anacostia Riverkeeper. So these are generalized volunteer responsibilities. So once you finish this training, Christine will give you a link to our certification test. She will give you a link to our waiver, our joint waiver. And then once you pass the certification test, signed your joint waiver, you'll be all set and trained and ready to go. And so once Christine or us in Anacostia Riverkeeper give you the thumbs up, you are ready to go. You are officially certified under this program. We will pass along the link for volunteer signups. So this is all done via a Google Sheet, which is a live document online that everyone has access to, all volunteers have access to, that'll update in real time with where people are monitoring and things like this. The only type of information you'll have to put in is your name and email address and phone number if you'd like to. And it just allows an easy location for you to see what sites you want to monitor, where you want to monitor, things like this. What this looks like is essentially this. The Google Sheet is basically just an online Excel sheet. For those of you who haven't used it before, you can just go I bookmarked the link on my web browser and just am able to access it every single day. You'll see on the left side there, we have the left column will have our sites. Obviously, those sites will say things like, Janice, I will go over time, location, and day to pick up sample materials in a second here, right after this. Sign up location, you'll sign up. So in this example, we have our friends Barack Obama and Joe Biden. They're big fans of Montgomery County water quality, and they're a big monitoring team, and they want to go out together. So in this example, they've signed up for January 20th there on Inauguration Day. It's a tough day to monitor, but they're going to sign up here on Inauguration Day to monitor AR1 and AR2. We provide 3 slots to monitor, but it can really be more or less if you'd like. COVID protocols are obviously still important. So if you feel uncomfortable monitoring with more people or strangers, we can work that out with you. We typically ask folks to black or gray out, shade the other lines in their site. So lines 2 and 3 there, you'd shade out and basically have yourself as the only monitor for that site. We also recommend that if you have 3 of you who are trained to want to go out and monitor, we've had that before. But if you're the only person trained and you want to go out to one of these sites and bring your grandma, your mom, your dad, your sibling, your aunt, your uncle, whomever, and they aren't trained, bring them on out. They can either get trained later or they can help you write down information. All that we ask and all the requirements that we have are that the person who is trained is the one who's actually physically collecting the data. So the folks who are filling up the bottles, collecting the samples, reading the air temperature, the pH, stuff like this. That's all that we ask. But you can bring as many people as you want to the site, and if they're interested in it, they can get trained later. If you have kids who are interested, they can get trained as well. They just need to go out with a parent or guardian. and things like this. So we like to make this as easy as possible for folks to go out, do it quickly, an hour in the morning every other Wednesday, and you're set to go. And we have tabs for each month there at the bottom of the sheet. So you can sign up for May. We won't release all of the signups all at once, i.e., we won't release May, June, July, August, September all at once. We'll release signups a month at a time, just so you don't go and sign up for some time in August and then all of a sudden it gets to August and you're like, oh no, I'm going to Aruba or something like that. So we'll release those a month ahead of time. This is our example sign up page for um, how it currently looks. You can see there down at the bottom, Mike Mills has grayed out the other two slots because he wants to monitor there by himself. And we also have a column for if you're available on the backup day, i.e., the Thursday, yes or no. So if you're not available, like Mike is here in this example there at the bottom, we would just either try and find another volunteer for Thursday if there was bad weather on Wednesday, or we would just take the samples ourselves. So before you go out in the field and what if you need to miss a monitoring date? That's a good question. If you need to miss a monitoring date, if all of a sudden that morning you wake up and you're like, oh no, I have a doctor's appointment or something like that, just let us know. That's the biggest thing. Just let us know. It's not a big deal. We have contingencies in place to make sure that sample is collected. But just make sure, try and give us at least 24 hours notice. I wouldn't, if you need to wake up in the morning and all of a sudden something happens and you need to email us, that's okay. But try and give us a day or two heads up so we can either try and find another volunteer or scramble to get that site monitored and covered. But don't stress out and rearrange your whole entire day if you can't monitor. It's not a massive deal. We're able to adjust to make sure that site gets sampled. But before you go out, you will have your supplies. I'll talk about that here in a second. We like to say talk with your monitoring group. So if you're a group of volunteers, make sure you know where you're going to meet. Make sure you know where your site is. Um, Make sure you look at the site list, the site coordinates, where the sites are, go out, see the site pictures. We also have the sites flagged with pink flagging tape that is this color. Um, so you're able to see where the sites actually are. And if you have any questions about that, you can let us know. Like I said, the sites are all accessible via a trail, stream side, has parking, stuff like that. So they're relatively easy to find. But we always like to make sure people know where they're sampling. Check your equipment, make sure your gloves aren't broken open and your thermometer works and stuff like that. One of the things you will have to provide, we provide sampling kits, which is packed into a lunch pail style cooler. One of the things you will have to provide is ice, because our bacteria samples and our turbidity samples, the physical bottles that you'll be collecting water into, need to be kept on ice. Just to keep that bacteria as cold as possible. So ice packs or ice are required. If you're picking up supplies that morning to then go out and monitor, we can potentially provide ice packs for you, but hopefully everyone has access to a freezer or ice or something like that. Make sure your materials are all there, make sure your forms are all there and stuff like that. But we'll also double check that in our lab and with us to make sure that's all there for you. So I'll go over where and how to pick up supplies after I go through the actual methods. But when you get out into the field, we always like to sample our sites at the same location. Obviously, it doesn't have to be in the exact pinpoint location in the water, but within a couple feet upstream or downstream of where we are, in the same generalized location of where we are. We always like to sample upstream. So if you've ever gone fly fishing, this is the analogy I like to use. You always point upstream for the most part, and a lot of times, because your water is flowing obviously downstream, so you get the most representative water sample as possible. And we'll go over the actual methods of how to collect each of these samples as we go. So, say you've picked up your supplies and you get to your site the first day of monitoring, and you're ready to monitor. You got your sheets ready, you got your cooler ready, you got your supplies ready. You get down to your stream site and you are ready to go. First thing you were going to sample for is air temperature. First thing you do when you get to a site, don't even take out your sheets or anything, get out your thermometer, and we're going to measure air temperature. Air temperature is measured always, exclamation point, asterisk, underline, bold letters. Air temperature is always measured before water temperature. So we always measure air temperature before water temperature, because if we were to measure water temperature first, if we were to take that thermometer out of the water would then be evaporating off that thermometer, causing it to artificially bias the temperature reading low. Very same phenomenon as when you sweat. The sweat evaporates and takes heat away from you. When water evaporates off something, it takes heat away from the thing it's evaporating off of. So we always measure air temperature first. If you're sampling multiple sites, obviously you're going to be kind of going back and forth. So if you go to one site, you get to your next site, make sure the thermometer is dry and you're ready to go before sampling air temperature. We just don't like to go from water temperature directly to air temperature. So you get to your site, first thing you do, measure air temperature. We have these nice Hana, I'm not sure how to pronounce it, digital thermometers. We had glass ones, we upgraded to the nice digital ones so they're easy to read. You just press that blue button in the picture and they will turn on. Air temperature takes a few minutes to equilibrate. It's a little slow. These are basically like meat thermometers in a way. But water temperature, very fast. So air temperature you take, and it takes a little bit to equilibrate. With air temperature, we always try and take it in the shade and over the actual stream if possible. Obviously, because that is the actual condition of the temperature of the water in that area, we don't like to take the air temperature in the parking lot because that's not representative of what the air temperature is around the water there. So air temperature, we got that. Relatively easy to sample for. You write it down on your field sheet, 28.1, as in this picture here, you're ready to go. So this is Olivia down in DC measuring air temperature here. So she's standing on a dock. You will not have to stand on any docks. These are all next to streams, all next on stream sides, stuff like that in the woods, in the forest. And so you'll be sampling over the water. This is our old thermometer. But sample over the water if you don't have shade, just to obtain that most representative sample. This is water temperature. So for water temperature, just imagine this is the newer thermometer. Some of them will and some won't have strings on them, but all of these are within crouching distance, we'll say. For water temperature, you just stick the bottom of the thermometer a couple inches into the water as much as possible. Some of these streams are only a few inches deep, and wait for it to equilibrate. This is a little bit faster with these thermometers. It only takes 30 seconds maybe to equilibrate. That can obviously change, but water temperature takes a little bit less. You wait for your thermometer to stabilize and you record that water temperature value. So air temperature and water temperature, first things you do, relatively easy. If you're in a big team, you can have one person recording the water temperature and air temperature, one person recording it on the field sheet, and the other person dancing in the background. Who knows? So the next thing we're going to sample for is pH, so alkalinity or acidity of the water. If you've ever had a pool or an aquarium, you will instantly recognize these. These are simple litmus paper, just a regular strip that has an orange piece of reactive paper at the bottom of it there, and you stick that in the water and allow it to equilibrate, and then it'll basically turn the color of the pH of the water, and you just read that off the tube there. pH strips go from 1 to 14. The water that we're sampling in will be between probably 6 and 8, but that doesn't mean it can't be something different. Obviously, if you go and collect a pH sample and it's like 1, that's something we would definitely like to know because that is some very acidic water. It's basically like Coca-Cola. So that's the type of information we want to know. Typically, these strips are a little finicky, we'll say. So they take around 2 or 3 minutes to equilibrate. We like to say allow that time to equilibrate. A simple little trick you can do is you can take the top of the turbidity bottle, not the bacteria bottle, the turbidity bottle, take the top of the turbidity bottle and the cap, fill it with a little bit of water, stick the pH strip in it so it's reacting, and you can just let that sit for a few minutes while it's reacting, instead of stooping over the water for 2 to 3 minutes. Because if you do it just for around 30 seconds, these strips won't have enough time to react with the water. And as you can see, that strip is inherently at a 4 or a 5. 99.9% of the time, the pH won't be a 4 or a 5, but it could be. But we just ask that you allow enough time for those pH strips to equilibrate. So this is a video of Olivia here taking the pH strips out. She goes down to the water, puts it in the water for a minute or so. and then she reads it on the pH tube what color it is. Relatively easy. Air temperature, water temperature, pH should all take you a couple of minutes. Nothing too severe there. And then you record your pH value on your field sheet, which I'll show you here in a little bit. Then we're going to get to the actual bottles that you are going to fill up. These are the actual quote unquote samples that you will be collecting. So we collect one sample for bacteria and one sample for turbidity. Bacteria we are collecting is E. coli. Turbidity is basically just how cloudy or how clear the water is. So first thing we're going to sample for is bacteria. This is a grab sample, it's called. Pretty easy to recognize. The bottle will be crystal clear. I'll show you in the next slide. But when we sample for bacteria, you have a bottle that is sealed, kind of like a jar of pickles with a shrink wrap around it. And you will have a white, what's called a preservative in the bottle. It looks like salt, essentially. That's because that bottle needs to be sterilized and perfectly secure all up until the time of sampling to make sure that the sample value is the most representative of what the bacteria are at that point in time. So when you go to sample, you're going to go to your stream side. You're going to face upstream. This is upstream for me. You're going to face upstream. You're going to take the plastic off. You're going to open your bottle. And then as this video shows, you will sample into the water, fill up the bottle, and you're done. So what Olivia is doing there is what's called decanting. So these bottles are about 110, 120 milliliters. For our sample, we need 100 milliliters. There is a raised ridge, a raised line on the bottle that says 100 milliliters. It is very distinctive. So we like to fill up to that line. If you fill over that line and you're like OCD perfectionist, you can what's called decant off a little bit until you get to that line. That is okay. What we do not want to do, exclamation point, big letters, star, the thing we do not want to do with these samples is fill the bottle and you're like, oh no, a leaf is in it, or oh no, I didn't get enough, and pour it out and then refill it. Because that preservative in the bottle, if you pour it out, it will pour the preservative out, and then that sample will not be valid. So you just go in one scoop all at once, and you get that water. If it's too much and you're nervous, you're like, I just want to collect my sample, cap it, you're good to go. If you're under that 100 milliliter line, please fill up a little bit more because we do need at least 100 milliliters for this sample. So that's all it is. And so once you collect your sample, it's in the crystal clear bottles that'll have a sealed wrap on it. This is what it looks like in a cooler. Once you sample that bottle, you can dry it off a little bit. We provide you with labels. They're basically like packing or shipping labels. You'll take one of these off. You'll stick it onto the bottle. You'll write information like the sample ID, the time you collected it, the date, and the time and stuff like that, your initials. You will put a piece of packing tape over it just to waterproof it and keep that label on a little bit. I like to use the Sharpie provided to write the site ID on top of the bottle. As you can see in this picture, someone has written the site ID on top of these bottles. So we have Doc 79, we have Sample 9, Site 1, Site 4, Site YP. Those are all site IDs. So that basically helps you if for some reason the label were to spontaneously combust off that bottle and totally be gone, we'd at least know where that sample is. Because if we have a sample bottle with no identifying information on it, we can't place that sample geographically where it came from. So we like to add our little bit of information right there. So what we need there is the important things for each sample is the sample ID, which is SC1, SC2, SC3, LB1, or NWB2 for our 5 sites for this project. And then we need the time. Those are the 2 most important pieces of information. You can record this on your chain of custody, which I'll go over in a little bit. But that's the most important piece of information. You collected your sample, you put it in the cooler. You're ready to go, you're done. Then you can move on to turbidity. For this project, we also collect what's called quality assurance samples, which makes sure the data is as precise and robust as possible. So every week we do what's called collecting a duplicate sample, which is exactly what it sounds like. So depending on what week and where you sample, we may ask you to collect a duplicate sample. We will expressly tell you you are collecting a duplicate sample. What this means is we just give you an extra bacteria bottle, and instead of collecting 1 bacteria sample, you collect 2 bacteria samples, the exact same way, one after each other. This is just so we can check how precise our methods are and stuff like this. But we will expressly tell you when you are collecting those. This is what the bacteria bottle looks like. Obviously, it has shrink wrap on the top, white cap. It is crystal clear. You can see through it. And there's that 100 milliliter beveled ridge right there that you can see. So that is the fill line we want to get to. Next, we have turbidity and bacteria, or we'll talk about turbidity in a second. This is the label that we have. So it has site ID, the initials, the date, and the time. Like I said, it's important to have the time and the site ID just so we know when it's sampled and where it came from. The time is really important for this because these bacteria samples, they have what's called a holding time of 6 hours. So that means from the time you collected that sample, say it's at 8 a.m., that sample needs to be run by 2 p.m. or 6 hours later, just because that's how much the preservative lasts, and basically because of the science and all the other stuff. If you were to read that sample or try and analyze that sample 12 hours later, it wouldn't be as representative of what the conditions were because those bacteria have grown too much, they've gone haywire, everything like this. So the time is important because it allows us to know, okay, when do we need to run or analyze these samples? So that's what the label looks like. That's what it looks like on a turbidity bottle there. You'll just put that on the bottle each time after you sample it, and you're good to go. Then we go to the last sample, which is a turbidity grab sample. So turbidity, like I said, is how cloudy or how clear the water is, how much light can pass through it. This sample bottle will not have any preservative in it, i.e. it's just a plastic bottle. It is opaque. You cannot see through it. And it is collected identically to the bacteria with one exception. So while bacteria, we scooped up the water and then we capped it. With turbidity, we're going to do what's called rinsing the bottle. So this is what the turbidity bottle looks like. It is also 100 milliliters, 120 milliliters, opaque, just a plastic bottle, no plastic seal around the lid. That's your turbidity bottle. And so how we collect them, so in this example, we have Olivia here. She's at a stream here in DC. She is facing upstream with a turbidity bottle in her hand. So when I say we rinse the bottle, that means we fill it up with water, then we pour it out, then we fill it up with water, pour it out, fill it up with water, pour it out. So that's 3 times we've rinsed it, and then we'll collect our sample on the 4th time. The reason we do this, it seems kind of silly. This is the EPA method, and for the method we use, how we sample for turbidity. It just makes sure you obtain the most representative sample for turbidity, and that there's no latent or excess or leftover dirt or mud or leaves or sticks or whatever in that bottle that's going to bias the sample. So in this video, Olivia fills her bottle once, pours it out, fills her bottle twice, pours it out, fills her bottle 3 times, pours it out, and then finally on the 4th time she fills it and she caps it. So this is where sampling pointing upstream is important, because for turbidity, say we're at this nice stream here like in this video, and it's full of sand, it's full of silt, it's muddy on the bottom. If we're stamping around there on the shoreline and we're pushing sand around and stuff like that, you can cause all that mud and silt and sand to plume up. And then if you fill that up, you're kind of biasing your sample with all that sand and turbidity and all that mud in there. So you're going to have a muddy sample. So if we were to do that, you're like, oh, shoot. What you can do is just take one step upstream, and then you're in totally new water because water is flowing downstream. So that's why we sample upstream. And in this example, when you're rinsing, you pour downstream, or you decant or pour downstream. So you fill upstream like Olivia did, and then you pour downstream. Fill upstream, pour downstream, fill upstream, pour downstream. Sample on your 4th time. So 3 rinses, sample on your 4th time. Seems kind of silly, seems kind of redundant, but I promise you this is the correct, proper method. And if you've noticed that you've kind of disturbed the bottom there, like I said, just take 1 step or 2 steps upstream, and you should be in totally new crystal clear water for the most part, unless it's already turbidity or already turbid, and then you're good to go. And so that's turbidity. You cap it, you'll label it the exact same as bacteria, you'll put a piece of tape around the shipping label, the exact same as bacteria, and you put it in your cooler, you're good to go. Just for your information, we at Anacostia Riverkeeper also have one of our water quality folks go around after y'all and use our YSI probe, which is basically a water quality probe, to sample for things like dissolved oxygen, specific conductivity, pH, and water temperature again. So when we present the results every other week, y'all will see the bacteria results, you'll see the turbidity results, all within context so you can kind of understand it a little bit. But you also see results for dissolved oxygen, specific conductivity, and stuff like that, which usually, asterisk, usually, it's pretty normal for a lot of these streams, which is great to see, all usually within healthy ranges in the summertime, with a few fluctuations here and there. But that's why we sample this, just to see if there's anything amiss going on. And like I said, this year as well, we're also sampling for nutrients, which will also provide information for as well. So for supply pickup and sample drop off. So our office for Anacostia Riverkeeper is down in Navy Yard in DC. That is a 30-minute drive without traffic, 45 minutes to an hour with traffic, especially in the morning. That's kind of a hassle for folks sampling in Silver Spring or Montgomery County. So what we've done is we've established kind of a satellite drop off and pickup location, at Tacoma Piney Branch Park. So this is kind of in the middle, all within a couple minutes drive of all of the sites. You can pick up, for actually picking up supplies, you can either 8:30 to 10:30. Yes, sorry. For actually picking up supplies, you can either pick up from ARC offices if you work in DC or you're around DC or you're just hanging out or whatever. You can pick up the morning of. So what we have volunteers a lot of times do is we'll be at the site from 8:30 to 10:30. Thank you, Christine, for correcting me. Every morning of sampling, every Wednesday morning of sampling. So if you're ready to go, you can just come out to the Tacoma Piney Branch Park, pick up your kit, drive to your site or sites, couple minutes drive, sample, and then you come back. You can be done within 30 minutes to an hour, and you're ready to go. And if you're sampling next week, you can either pick up supplies when you drop off your supplies, or if you're not sampling for another month or two, you can just go on your merry way. Friends of Sligo Creek folks and some neighbors of Northwest Branch folks have also worked up, you can work out special pickup locations. Like if you have someone who lives around all of these sites, last year we had a volunteer graciously offer to use their porch or garage or whatever it was as a satellite pickup location for supplies if you can't pick up the morning of or anything like that. So that can be worked out, and we'll work that out before monitoring comes here. Or if you have one person in your volunteer team is like, I'll just go pick up supplies, they can go pick them up and y'all can pick them up from their house or something like that. But the main typical ways will be either from ARC offices or the morning of at Tacoma Piney Branch Park there. Samples can then be dropped off either at our ARK offices, aka if you're sampling and then you're driving into DC or whatever reason, you can drop them off at our offices directly, or how most people have dropped them off is at our satellite drop-off location at that Tacoma Piney Branch Park. So there will be an ARC or an Anacostia Riverkeeper staff member at the satellite drop-off location from 8:30 a.m. to 10:30 a.m. each morning of monitoring. So we give you kind of like a 2-ish hour window to pick up supplies and monitor and stuff like that. That's more than enough time for y'all. The address for the park is right there below. It's also written all over everything. Tacoma has a K, not a C. You are correct. And so that has all the information you'll need about that. If you can't pick up or drop off or anything like that for whatever reason, or just email us and let us know, we can try and work something out. But in the years past, especially last year, this has worked pretty well just because it's super convenient and accessible to all of the sites. Yes, there's parking at the park. There's parking. I believe Christine or me or one of our other water quality folks will be under a pavilion or something like that.
There's a full parking lot from one side, and then there's street parking from the other entrance. So there's plenty of parking in the area, and then yes, there's a pavilion section that you'll be able to find us at.
And we'll have supplies for the next week of monitoring if you need to pick those up. We'll have questions and answers for anything you have, or just want to talk or anything like that. We try and make it as easy as possible and as quick as possible if we know you have stuff going on throughout the day. So we try not to make this too much of a logistical hurdle or time suck for folks. So just so you know, in the field, like I said, you're collecting the air temperature, the water temperature, the pH data. You get that immediately in the field. You have that information. But the lab and turbidity samples we actually need to run in our lab. So just so y'all know, um, we need the ice because we want to keep those bacteria samples cold. That's required of them. We typically like to have our samples all within 5 hours so we can run them within the 6 hour time. So in the lab, what we do for bacteria, we use a very simple method that is, y'all don't really need to know this, but I like to explain it just so you know what's going on behind the curtains, so to speak. Um, this is very similar to the method you may have seen like or done back in like 8th grade biology with the little plates and you see the bacteria colonies growing on them, and it's that classic science picture that's probably on every biology textbook for the last 20 years. This is a method that was kind of built off of that and is very similar. So we basically take your bacteria sample that you collect, we bring it into our lab, we pour what's called a reagent into it. Um, that's basically essentially just bacteria food. It's like a yeast, I think, that has a special chemical in it. We allow that to dissolve. We then pour it into these, we call them trays or that grid there on the right. We seal it and then we put it in our incubator, which is there on the left. That incubator basically stimulates the bacteria and simulates what would the conditions be in a warm-blooded animal's guts, basically. And so we have that going for 24 hours, and then it allows the bacteria to grow, allows the bacteria to populate, and that special chemical that we had in the reagent, when the bacteria eat that reagent, they basically ingest and have that chemical work into their bodies. And so that happens in 24 hours. The bacteria would then fluoresce under black light. So when we analyze or read the sample, as we call it, we essentially take the trays out of the turbidity or out of the incubator, and then we put them under this black light reading device, we'll call it. And we count the number of glowing or fluorescing bubbles there, and then we read it out, cross-check it on a chart, and that's how we get your actual bacteria values. For turbidity, we essentially just do a similar process, but we use what's called a turbidimeter, which is essentially a machine that shines light through the sample to see how much light is passing through the sample. Um, Most of the sites that we collect at have relatively low turbidity, which is good, which means crystal clear water. Um, so that's always important. And so the two forms that you are going to fill out are what's called the chain of custody and the volunteer field sheet. So we're getting towards the end here. This is an example of the chain of custody. If you ever watch like a Law and Order, or a police procedural, or something like that, you've probably heard the word chain of custody. Used for evidence, all these stuff. In science, it's used in labs to say who has taken the sample and then who has received the sample. It's basically a list or a pathway for who has handled this sample. So you put your name on there, the sample ID, the easiest part in this middle part here, where the Anacostia Riverkeeper logo is, you can equate one of those rows to one physical bottle in your cooler. So if I were to go to one site and I were to sample my normal samples, bacteria and turbidity, I would fill out two of those rows. So I'd fill out my sample ID, my date, my time, my analysis. If I had two rows filled out, I did bacteria and turbidity. They were normal samples, and you can add remarks if you want. Think of this as a list or an index of the number of bottles in your cooler. If you were to go out to a site and collect your regular samples and a duplicate, you would then have 3 bottles in your cooler because you have collected a bacteria sample, a turbidity sample, and then your duplicate bacteria sample. So sometimes this can confuse people, but the easiest way to think about it is when you drop off your samples, I should be able to open your cooler, count the number of filled bottles in your cooler, and then that should be the same number of rows you have filled out here on the chain of custody. If you have questions, when you come to drop them off, we can walk you through it for the first couple times. But this, then you will at the bottom here, you'll put the time, the date, and put your name that you relinquished them, and the person at the satellite drop-off location will sign it as well, saying that they received them. So this allows us to track, okay, what samples do we have? Who had the samples? If there's a missing sample, we can trace it all the way back to you to be like, do you have this sample, or did you collect this sample, or something like that. This and what did they sample. So this is the chain of custody. Here's an example of a really long one. So I went out and sampled here. I had all these samples in here. I relinquished it on May 27th, 2020 at 12:15, and it looks like our lab assistant Marty Cruz received them by 12:29. Um, and so I filled out my name at the top, and then there in the middle, all of those sample IDs, SC1, SC1 dupe, SC1, all of those sample IDs are just bottles in the cooler. So there are probably like 15 lines there. That means I just had 15 bottles in my cooler. So that's typically what a normal chain of custody will look like. This is your field sheet. So this has all of the information you'll have to know and fill out on your field sheet. Has things like a site name, so it'll be in your training manual. Northwest Branch at Burnt Mills, that's a site name. Site ID, that site ID would be NWB-2. And then you fill out the date and the time. If you have someone helping you, they are just being a scribe. You can write them down as a recorder, and then if you have multiple people monitoring, you can fill out all the monitors there. The next section is just the physical observations of the weather. Is the water surface calm or ripply or other whitecaps? It'd be weird if there were whitecaps, considering these are all small tributaries, but hey, you never know. Stream flow rate, weather type, watercolor, all this stuff. Now, I know for some of y'all who maybe only bypass these streams or don't look at them actively, um, this is all subjective. I may know what a normal stream flow rate for some of these streams are, but other folks may see that as high or low. Just use your best judgment. If you go more often, you'll start to see what a normal stream flow is versus high versus low, and stuff like this. Don't tie yourself up in knots, being like, oh my God, is it normal? Is it high? Whatever. Just do it based off what you determine the stream flow rate to be, what the watercolor to be, things like this. We also provide sections for other observations. So if you see some dead fish, a lot of erosion, if there's like a lot of foam on the water, stuff like that, circle those if they're there. That gives us a little information. The next section is the section where you put your air temperature and your water temperature and your pH measurements and stuff like that. You won't have to do the YSI GSS probe. That's for us to fill out. The section below that is just a little checklist for you. So before you leave each site, you can go down those rows and be like, okay, yes, I collected my bacteria sample. Yes, it's labeled. Yes, I collected my turbidity sample. Yes, it's labeled. Yes, they're in the cooler. Yes, I filled out my chain of custody. No, or yes, I filled out or collected a duplicate. That's just a double check on you before you leave the site. And then there's a notes section as well, and then an internal section for us at Anacostia Riverkeeper to record rainfall and stuff like this. The notes section can just be anything. You can be like, I saw a mallard today. But it's also important to know you can write things like, saw a lot of trash. All those little bits of information are important for us because they provide context and a little more information about the site, because y'all are kind of the eyes and ears of us out in the watershed because we can't be everywhere at once. So if you're out there and you're like, well, there's a lot of trash consistently at this one site, we're able to take that information and send it to Montgomery DEP or State of Maryland or whomever and get them to investigate it. So this is what an example filled out sheet looked like. So I went out to Sligo Creek at Fleetwood Terrace, which I believe is SC-1. I was the only one there. It was ripple. Stream flow rate was normal. It was overcast, normal. I saw a small oil slick there. I filled out my air temperature and my water temperature. And then I personally had a YSI probe with me, so I filled out that information as well. And then I filled out the little checkbox as well there. Very simple field sheet. Just make sure you filled out all the required information on there as possible. So for when we upload our data, so one of the whole reasons we do this project is to, yes, test the water, make sure it's healthy, and all of these things. But it's also important because water quality data, especially now, whether it's collected by the government or whomever, sometimes isn't made publicly available. So it's not as useful to the people who need it the most, which are y'all, especially recreational water quality. If you wanted to walk your dog who wanted to go swim in the stream, if you wanted to wade through one of the streams, God forbid on a beach somewhere you wanted to go swim or something like that. So recreational water quality is really important and really mostly important to the folks who are recreating, obviously. And so we wanted to provide publicly transparent, up-to-date water quality data for community members, visitors to the Anacostia watershed. So on Thursdays, when we get all our data, we're able to analyze it all and get all of our data points. We upload it all to social media. We put it on our website. We put it on a few apps called Swim Guide and Water Reporter, which I'll talk about in a second. We'll handle My Montgomery Green MC, Bay Trust, all those folks. We try and spread this data as far as possible. We also encourage y'all to take pictures when you're out there, tweet them, upload them, put them on Facebook, wherever. Um, they're good to share the program, but they're also good um, to show us things. If you see a lot of trash somewhere, snap a picture of it and send it to us. And that way we're able to see it in real time. So we always encourage folks to take pictures, send them to us, email them to us, tweet them out, put them on Instagram, however you'd like. We want to share this project and the data from this project as far and as wide as possible, just so people are as informed about their waters as possible, but also just people may learn a little bit of thing about their local watershed or their local stream or something like that. Two of the apps that we upload our data to are Swim Guide and Water Reporter. So Swim Guide is a Waterkeeper run app that you can actually get on your phone. So if you want to get a Swim Guide on your phone, you can just go to the App Store and get it. It's not just based around here; it's based internationally for the most part, but mostly nationally in Canada and the U.S. So if you're going to say like Lake Erie or something like that, and you were like, "Oh no, I want to know if it's safe to swim here," there could be a waterkeeper or someone posting results onto Swim Guide here to tell you if it's safe or unsafe to monitor. It uses a very simple red is failure or it does not meet standards for swimming, green, it passes, it would be safe to swim here kind of thing. Very simple red, green. Green means go, red means stop demarcation. If you're a little more interested in the nuts and bolts of the data, we use Water Reporter as well, which is the map we embed on our website and some stuff. This gives actual point locations for the site, gives very similar red and green pass fail sort of thing for the sites as well. But you can also go in and click each of the parameters and it'll give you graphs, it'll give you trend lines, it'll give you all this stuff. So you can see, oh, the dissolved oxygen was high in the beginning of the summer, low in the middle of the summer, and it's gone back up towards the beginning of fall, or see if bacteria results have any trends or anything like this, which is really interesting in the summer, but it's also interesting because it has last year's data and the years before data as well. So this has all the data for that specific site as many times as we've collected it. So some of these sites have 3 years worth of data. So you can actually see 30, 40 data points across all these years, which is really interesting to see, oh, the bacteria has always been high here. Oh, or the bacteria has kind of fluctuated here. So that's a really interesting app to use. Also an app you can get on your phone and also use to report pollution as well, which is pretty interesting. Um, yes, ARK posts water quality data on Swim Guide as well. So we post water quality data on Swim Guide. We post our water quality data on Water Reporter. We also provide our water quality data to what's called the Chesapeake Monitoring Cooperative, which is a Chesapeake Bay wide data repository, for lack of a better term, run by an organization called the Alliance for the Chesapeake Bay, who we actually work with in DC. And this is something for those of you who want to look at the Anacostia data or this Montgomery County data in the larger context of the Chesapeake Bay. And so this data is essentially, this data is good that it's shared far and wide and that it's public, but it's also, we want to use this data to its max capacity, we'll say. So this data is also sent to the Chesapeake Bay program via this CMC, the Chesapeake Monitoring Cooperative. So y'all get the data, Maryland gets the data, Maryland State gets the data, Montgomery County gets the data, Chesapeake Bay program gets the data. So this data is spread as far and as wide as possible, just in case whatever's going on, people can make informed decisions about swimming, about water quality, all these things. So again, the biggest part of this project is to try and collect this data, but share it as transparently and as accessibly as possible. these are the example here on the left is from the CMC. This is what the map looks like. So that's where our data is there. Other organizations post their data here as well. The example here on the right is a social media post example of what we may post on our Instagram or Twitter or something like that. Do you know what office gets data in Montgomery County? Yes, we send our data to Montgomery County DEP, specifically the Office of Water Resources or whatever that office is called. We send our data to Montgomery Parks as well at the end of the year. We send our data to the Maryland MDE. We send our data to anyone who asks for it, really, and then we upload our data to Chesapeake Bay program. So this data is going to local, state, and federal decision makers. So it's seen by everyone, hopefully. But yes, we do send it out to folks in Montgomery County and higher up and lower down. Finally, so the last piece of knowledge, tidbit of knowledge I'll convey is the standard for when we say something is passing or failing. So one of the biggest things in urbanized watersheds in collecting recreational water quality is what is the standard that says, yes, it would be safe to contact this water, and no, it is not safe to contact this water. So this standard, there's a EPA federal value typically that the EPA uses. States can set their own values or their own thresholds, whichever you want to call them. So it can either be a state decision, say you wanted to go swimming in Virginia at Virginia Beach. Virginia would say it is safe or unsafe to swim at Virginia Beach based off of the state of Virginia's thresholds or standards. So we use Maryland's, which are also the same as the EPA's. Typically, most states use the EPA's standards. Some states use slightly different ones. But we use these, which are the same for the EPA and state of Maryland. So, what these standards are, what this physical limit is that says, yes, it's safe, no, it is not safe. There are two things they look at. One of them is called a single sample value, and the other thing is called a geometric mean. The best analogy I've come up with for this is imagine single sample value is like weather, and geometric mean is like climate. So the single sample value is the physical conditions of that sample, of that body of water where you just collected your sample at that point in time. It could have rained the night before, it could have snowed the night before, it could be dry and crystal clear. Those bacteria results are the representative of that point in time, just like the weather. It could be rainy tomorrow, could be sunny tomorrow. Geometric mean basically takes the average of 5 samples over a month span to give you a more representative overview of what the water quality conditions are at that one point in time, i.e., it's like the climate. So in DC, it's mostly humid and a little rainy sometimes in the afternoons in the summer in DC. So geometric mean takes 5 of those single sample values, averages them together, and that's what basically policy decisions are made off of, permitting decisions are made off of, and stuff like that. So that gives you the overall trend for water quality, specifically of bacteria in that water body, while the single sample value is more relational to you on if I would want to swim in that water body at that given point in time, because that is the current conditions of the water at that given point in time. So the values for this project that we present to you, what we say if it's passing or failing on, what we say if it's red or green on, this whole thing, this is based on the single sample value. Because we do it bi-weekly, we can't obtain a geometric mean for the most part. So we are giving you the single sample value. So we are telling you, yes, it passes, yes, it's failed at this point in time, which is most relational to you, for lack of a better term. If you wanted to go contacting that water, i.e., if I want to go kayaking on the Anacostia right now, or swimming on the Anacostia right now, or swimming in the Northwest Branch right now, I care about if that water would be safe or not safe to swim in at this given second when I'm recreating. I don't care about the general water quality trend because that's whatever. I care about if it's safe at this point in time. So when we are giving you the pass fail, this is what we're basing it off of. That's a very generalized version of it, but just so you know, when you check the data and you see green is passing, red is failing, this is what we're talking about. We also provide you information on passing or failing thresholds for like dissolved oxygen or anything like that. But those are just for your information to contextualize the data. This is the most important one for overall water quality, overall recreational water quality at the site. So that brings a close to the technical part of the training. So now, what time is it? It is 11:11 right now. Make a wish. Right now, the next steps will be to take the certification test, then to fill out the project/ARK waiver, the bottom part only. And then once you do that, you will be officially certified and can sign up for monitoring. So how this is going to go is Christine is providing some links in the chat right now. We will stay on for 20 minutes ish, 30 minutes ish, to answer any questions. To answer any questions about the certification test, hint, hint, nudge, nudge. So if you want to take the certification test now, we will be on the line to answer any questions about that. Wink, wink, nudge, nudge. Fill out the project waiver, and Christine has also just emailed all the information to you. So once you have passed the certification test, Christine said you're good to go, and you filled out the waiver, she will email you, or one of our water quality folks will email you the actual sign-up sheet in which you can sign up to start to monitor. Monitoring starts on May 18th, so 2 weeks from yesterday. And there's also a link to our water quality volunteer site. So if you want all this information prepackaged in a nice little location, we created a Google site. So this will have weekly or bi-weekly data, current data that we upload. It'll have training manuals. It'll have all this PowerPoint information. It'll have all of the information y'all need in a convenient online location. So it's basically a resources depository for all this information. So with that being said, I will open it up for questions that folks can either ask in the chat or just shout them out. And thank you all for coming out.